This is paper 3H, calculator paper from practice test set 6 for the new Edexcel GCSE. Question 1, here is a rectangle. Rectangle has been divided into two strips, A and B, and the strips have the same width. So A is half of the rectangle and B is the other half of the rectangle. 2/5 of strip A is shaded and 5/8 of strip B is shaded. The length of the rectangle is 40 centimeters. What fraction of the rectangle is not shaded? And it's asking what fraction is not shaded. So for me, I see that 40 centimeters as a bit of a distraction. I don't need to know the length of the rectangle because I don't know the width of the rectangle. So I'm just going to do it all with fractions. If that's 2/5 that's shaded in here, that must be 3/5 that unshaded. And if that's 5/8, that leaves 3/8 unshaded. Now each of these is half of the rectangle overall. So if I want to know what fraction of the rectangle this is, that's 3/5 of 1/2, which is the same as 3/5 times 1/2, 3/10. And unshaded here, that's 3/8 times by a half, 3/8 of a half, which is 3/16. And this is a calculator paper, so I need to add those fractions together. 3/10 plus 3/16, which gives me 39/80 on my calculator. So that's the answer. The unshaded region is 39/80 of the whole region. To check that, I suppose I could do 2/5 of a half plus 5/8 of a half, and that would hopefully lead me to 41/80. What it would do. Question 2. Make W the subject of the formula P equals W minus 3/2. This is a fairly straightforward rearrangement. So multiply both sides by 2 to get rid of that denominator, and that gives me 2P equals W minus 3. Add 3 to both sides. 2P plus 3 equals W. So W is now the subject of the formula. W equals 2P plus 3. Question 3. A, B, and C are 3 service stations on a motorway. AB is 25 miles, BC is 25 miles. Aisha drives along the motorway from A to C. Aisha drives at an average speed of 50 miles per hour from A to B and 60 miles per hour from B to C. So I'm just annotating the drawing as I go. Work out the difference in the time that Aisha takes to drive from A to B and the time Aisha takes to drive from B to C. Give your answer in minutes. Well, I can take a formal standard method with this, but actually the first thing I think to do here is if she's driving at 50 miles per hour for that and it's 25 miles, that means she's going to take half an hour. It would take her an hour at that speed to go 50 miles. She's only going to go half. So she's going to travel 50 miles in an hour, 25 miles in 30 minutes, half an hour. This one, she's travelling at 60 miles per hour. That means she's travelling a mile a minute. So to cover 25 miles is going to take her 25 minutes, meaning the difference in time is 5 minutes. If I was going to use a more formal method there, I would say that if speed equals distance over time, and I need to know difference in time, I'll look at time equals distance over speed. So for the first bit, time equals 25 over 50. And for the second bit, t equals 25 over 60. 25 over 50 is half an hour. And 25 over 60 is 5/12 of an hour, which, if I multiply that by 60, to get it in minutes is 25 minutes again. So 30 minutes, 25 minutes. And then I've got those 2 times ready to compare. So difference between A to B and B to C is 5 minutes. Question 4. Solve the simultaneous equations. 4x plus 3y equals minus 7. 3x minus 4y equals 26. I have to have either the same number of x's or the same number of y's. For this one, I'm going to get it in a position where I have the same number of y's so that I can add this equation to this one and eliminate the y's. So I'm going to take this first equation, equation 1, and multiply it by 4 so that I end up with 12y. That gives me 16x plus 12y equals minus 28. And I'm going to take this equation, equation 2, and I'm going to multiply it by 3 again so that I end up with minus 12y. So that's 9x minus 12y, and 3 26's is 78. And then I'm going to add these equations together, and that gives me 25x equals, because 12y added to minus 12y is 0, 78 minus 28 is 50, so x equals 2, and I divide both sides by 25 there. X equals 2. I now need to go back to my original equation, so sub into 1. X is 2, so 4 times 2 plus 3y equals minus 7, so y must be a negative number here. That's 8 plus 3y equals minus 7. Subtract 8 from both sides, and that gives me 3y equals minus 15. Divide by 3, and y equals minus 5. So I've got my two answers, and of course I want to check that because it's one of the questions that I can check simultaneous equations. So checking this, sub into equation 2, the equation I haven't used so far. So 3x, 3 times 2, minus 4 times minus 5 equals 26. That is 6 minus minus 20 equals 26. 6 plus 20 equals 26, which is true. So I've got my answers correct. X equals 2 and y equals minus 5. Question 5. Toby invested £4,500 for 2 years in a savings account. He was paid 4% per annum compound interest. How much did Toby have in his savings account after 2 years? The easiest way to do this, the quickest way with a calculator, the original £4,500 times by 1.04, which is an increase of 4% per annum, squared because it's 2 years. Which gives me 4867.2. Another way to do that, if you were going the slow method, would be to say 4% of 4,500 is £180. So after 1 year, you'd have £4,680. 4% of 4,680. Find out what the 4% of 4,680 is and add it to that, and you'll end up also with 4867.2, which should be written as £20, because that's how we write pounds and pence. Jasper invested £2,400 for n years in a saving account. He was paid 7.5% per annum compound interest. At the end of n years, he had that much, £3,445.51 in the savings account. Work out the value of n. Well, for this one, after 1 year, he's going to have 2,400 times by 1.075. It's not 1.75. That would be a 75% increase. People often make a mistake with that. So 7.5%, the 7 is the bit that goes here, 1.075. Which is 2,580. And I can just keep going year by year. So that's after 1 year. 2 years, times by 1.075 again. That previous answer, that's 2773.5. And I can keep on going like that. 1.075, 3 years, 298, 1.5, 4 years, 3205.1, getting a bit closer. 5 years, 3445.510. So that's it after 5 years. N equals 5, it's after 5 years. I could also have looked at that whole situation with setting up an equation, which might not be the first thing that people want to do with this, but if I have 2,400 times by 1.075 to the power of n, because it's happening for n years, that would be £3,445.51. If I divide both sides by 2,400, and that leaves me with 1.075 to the power of n equals 1.4356, etc. I would then, at this level of maths, at GCSE level maths, I would then keep on just multiplying 1.075 by itself until I got to this number here, and that happens when n equals 5. So 5 times itself gives me that number there. Question 6, here is a shape. BPC is a semicircle. BAC is a right angled triangle. BC equals 8 centimeters, AB equals 5 centimeters. Work out the perimeter of the shape. Give your answer correct to 3 significant figures. So we've got 2 unknown things to work out here. We've got this arc length here, which is a semicircle, and we've got this straight line, which is part of a right angled triangle, so I can use Pythagoras for that. So I'm going to call this one x and work out what that is. Using Pythagoras' theorem, x squared equals 8 squared minus 5 squared. That's because 8 is the hypotenuse opposite the right angle, it's the longest side. So x squared equals 8 squared minus 5 squared, x squared equals 64 minus 25, x squared equals 39. So x equals the square root of 39, which equals 6.24499, etc. So that is this length AC. Semicircle. Well, the circumference of a circle is given by pi d, pi times the diameter, and semicircle is going to be half of pi d. So that's half times pi times by diameter, which is 8. So that's 4 pi, which on my calculator is 4 times pi equals 12.56637. Perimeter. My answer needs to be to 3 significant figures, so I'm just going to add my answers to 5 significant figures to make sure I'm going to round correctly in the end. I've got this BPC, which is 12.566, 56637, plus 6.24499, which is this length here, x, plus 5, the remaining side of the triangle, and that equals 23.8113606. So to 3 significant figures, I just look at the first 3 digits here, 2, 3.8. And I don't need to round up because it's a 1 afterwards, so 23.8 centimeters is the perimeter. Question 7. The diagram shows a trapezium, x plus 6, 3x minus 4, x minus 1. All measurements on the diagram are in centimetres. The area of the trapezium is 119 centimetres squared. Show that this equation is true. Well, in order to do this, I need to start off with my formula for the area of a trapezium, which is, if we know the parallel sides are A and B, which we know they're parallel here because of the right angles, and this is the height of the trapezium, the area is the average of these two sides multiplied by the height. So area equals A plus B over 2 times by h. So in this case, our A plus B is area equals x plus 6 plus 3x minus 4, the opposite two sides, all over 2, multiplied by x minus 1. And the area equals 119 centimetres squared, so that equals 119. And so far, I don't know that it's going to end up like this, but I do what I can, and I work through it logically, and hope that this comes out as the answer. So x plus 3x, collecting like terms, that is 4x plus 6 minus 4 is plus 2 over 2 times by x minus 1 is 119. I've put the x minus 1 in brackets because everything here is multiplied by everything here. In fact, I could do that to make sure I don't make a mistake with brackets. 4x plus 2 over 2. I could multiply both sides by 2 and multiply all terms by 2, but actually, seeing as 4 and 2 both divide by 2, I can just simplify that fraction and do the division, which is 2x plus 1 times by x minus 1 equals 119. And now expand these double brackets, so firsts, outsides, insides, lasts. Firsts, 2x squared. Outsides, minus 2x. Insides, plus x. And lasts, minus 1 equals 119. Collect like terms. 2x squared minus 2x plus x is minus x. Minus 1 equals 119. And now I have to see where they want me to end up. They want it equal to 0. So in order to do that, I have to subtract 119 from both sides. 2x squared minus x minus 120 equals 0, which I have shown to be true here. Because it's a show that question, I really need to start from the basics, so I start from setting up this equation. There'll be a mark for that. And work through stage by stage, no shortcuts, otherwise you haven't fully shown that it is true. So any show that question you're working needs to go very carefully, step by step, showing what's happening at each stage. And that's my answer. Find the value of x, show you're working clearly. This one, I'm hoping to be able to factorize this. So I've got 2x squared minus x minus 120. That means my brackets must start with 2x and an x. And 120, a bit of trial and error here. Or using a formal method, which I might need to do. In this case, it's probably not that complicated. I can use the formula, which is x equals b squared minus 4ac. Sorry, I've skipped a bit. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So we've got a is 2, b is minus 1, and c is minus 120. So x equals minus b, so that's minus 1 is plus 1, plus or minus the square root of b squared, which is minus 1 squared, minus 4 times a, which is 2, times by minus 120, that's c, all over 2a, 2 times 2. That equals 1 plus or minus the square root of Minus 1 squared is 1. Minus 4 times minus 2 times minus 120 gives me a positive answer. Minus 4 times minus 120 means that it's 1 plus 960 over 4. So that's 1 plus or minus the square root of 961 over 4. And that is 31, the square root of 961. So that's 1 plus or minus 31 over 4. So that's either 32 over 4 or 1 minus 31. So that's minus 30 over 4. So when I do those, 32 over 4 is 8, or minus 30 over 4 is minus 7.5. Which tells me if I'd done this one, I would have got 2x minus 15 plus 15, 2x plus 15, and x minus 8. Just check that works. I've got the right thing. 2 8s are 16. Minus 16 plus 15 leaves you with minus x, and 8 15s are 120. So if you'd spotted that, well done. If you'd used a formal method to get to that, that's fine. It is a quicker way. This one is a surer way. The reason I jumped to this is because I wasn't spotting it. So I thought rather than waste time going through all of the different outcomes, I would just use the formula to help me there. I'll get you the same result anyway. So if 2x plus 15 equals 0, then that leaves with x equals minus 15 over 2, which is the minus 7.5 bit, or x equals 8. Here is a number line. Write down the inequalities shown on the number line. Well, I can see x is to the right of minus 1, so it's greater than minus 1, and because it's a filled-in dot, that means that that number is included as well. So x is greater than or equal to minus 1. If it had been an empty dot, an open dot, that just would have been x is greater than minus 1. P is an integer, whole number. Minus 5 is less than p, which is less than or equal to minus 2. Write down all the possible values of p. P can't be minus 5 itself, but it can be the next number up, which is minus 4, minus 3, minus 2. Only 3 possible numbers that p can be if p is a whole number. New question, part C. Solve 5y minus 2 is less than 18. Solve this like an equation. Add 2 to both sides. 5y is less than 20. And divide by 5 to get y on its own. Y is less than 4. And that's the solution to that. So some quite straightforward inequalities questions there. Question 9. There are 9 counters in a bag. There is a number on each counter. Cal takes at random 3 counters from the bag. He adds together the numbers on the 3 counters to get his total. Work out the probability that his total is 6. So he's taking 3 counters from the bag. The probability that his total is 6. I have to think about the number of ways this can happen. And normally I would choose a sample space diagram. Seeing as he's taking 3 counters from the bag, that makes a sample space diagram more difficult. So I'm going to use a tree diagram for this one and look at the totals that are possible each way, the ones that I'm interested in. So first counter, second, and third. If his first counter is a 1 and he needs to end up with a 6, he needs to then get 2 followed by a 3 or a 3 followed by a 2. And I'm not interested in any of the other outcomes, so I'm not going to list them here. If his first counter is a 2, he'll need to get a... Well, in fact, the only way he can end up with a 6 is by getting a 1, a 2, and a 3. But he can do that in lots of different ways. But we'll see how that works here. So he can get a 2 followed by a 1 followed by a 3, or a 2 followed by a 3 followed by a 1. Or he can pick his 3 first, which means he will have to then get a 2 followed by a 1, or a 1 followed by a 2. As I'm doing this, I'm fairly sure there is an easier way to go about this, but I'm going to follow through this working because it was the first thing that I thought to do. So imagining I was in an exam, I would follow through this working. So 1, 2, 3. Probability of him choosing 1 first of all is 2 out of the total of 9. Probability of him choosing a 2 after that is 3 out of the remaining 8. And then 1, 2, 3, 4 out of the remaining 7. Here, that would be probability of getting a 3 would be 4 out of the remaining 8, followed by 3 out of the remaining 7 for a 2. Probability of getting a 2 first time would be 3 out of the 9, followed by a 1, 2 out of the remaining 8, and followed by a 3, 4 out of the remaining 7. And here again, there's a pattern going on here. So 3 would be 4 out of the remaining 8, and a 1 would be 2 out of the remaining 7. And 3 again, I'm going to keep on labeling these, so that's 4 out of 9, 2, 3 out of 8, 1, 2 out of 7, 3 out of 7, 2 out of 8. So every time I've got these, this one is 2 times 3 times 4 over 9 times 8 times 7. This one is 2 times 4 times 3 over 9 times 8 times 7. And we can see that this pattern, 3 times 2 times 4 or 3 times 4 times 2, this is always going to be the same. It's going to happen 6 times. There are 6 possible outcomes or orders of outcomes that work. 1, 2, 3, 4, 5, 6. So I'm going to do this and add the answer together 6 times. So 2 times 3 times 4, 24 over 504. And I'm going to do that 6 times, so 6 possible ways of doing that. 6 times 24 over 504. (144) over 504. And that's the answer, but of course it can be simplified to 2/7. So that's my answer to that one, 2/7. Question 10. The highest common factor of 140 is x and 20. The lowest common multiple of 140 is x, and x is 420. Find the value of x. So if I break down 140 into its prime factors, that's 14 and 10, which is the same as 2 times 7 times 2 times 5. I don't know what is in x, but if I look at these, the highest common factor of 140 in x is 20. So if this is 140 and this is x, the factors they have in common multiply to 20, which is 2 times 5 times 2. 2, 5, 2. And the remaining factor of 140 is 7. And when I multiply all of these by the number that's missing in here, I would get to 420. So 7 times 2 times 5 times 2, that's 20 times 7 is 140. And what do I need to multiply by that by to get to 420? So 420 divided by 140 is presumably 3. Yep. Which means that the 3 must be in here. So x is the result of multiplying these together. That's 2 times 2 times 3 times 5, which is 60. So x is 60 in that question. There may be other ways of doing that logically, but seeing as I know and use this method, that's the one I'm going for with that one. A number is decreased by 15%. The result is 323. What was the original number? This is the same type of question as the price after a sale. It's an inverse percentages question, working backwards, or reverse percentages. So my number decreased by 15%. 100 minus 15 is 85. So 85% of my original number is 323. My original number times by 0.85 is 323. If I do that in reverse, 323 divided by 0.85 equals missing number, which is 380. And of course, in an exam, I want to check that that's correct. So 380, 15% of 380 is 57, and 380 minus 57 equals 323, so that's correct. Question 12, Venn diagram question. Each student in a group of 32 students was asked the following question. Do you have a desktop computer D, a laptop L, or a tablet T? Their answers showed that 19 students have a desktop computer, 17 have a laptop, 16 have a tablet, 9 have desktop and laptop, 11 desktop and tablet, 7 laptop and tablet, and 5 have all three. Using this information, complete the Venn diagram to show the number of students in each appropriate subset. Subset being the part of the circle that, each region of the Venn diagram. As always with this question, a question like this, the first thing you need to fill in is the central overlap section, where L intersects D intersects T. And that is 5 that have all three, so put the 5 in there. In this section is people who have laptops and desktops. So laptops and desktops is 9. So if there are 5 of those 9 in there, 4 of them remaining in here. 7 students have both a laptop and a tablet, so laptop and tablet in here, and 7 of them, so 2 goes in here. And then we've got 11 that have both a desktop and a tablet. So 6 to make the 11 in there. Then we look at desktop overall is 19. So in the whole circle of D is 19, so 10 plus 5, 15, which means there are 4 remaining, and now this adds to 19. 17 students have a laptop, 5, 6, 7, 11, and I've got to get to 17, so another 6 in there. And T, we've got 16 with a tablet, 5, 6, 7, added 6 makes 13, and we've got to get to 16, so there are an extra 3 in there. And then of course there's the part outside the circles, people who don't have any of these. We're told that it was 32 people in total. So in order to work out how many are left outside, I've got 32, well let's add all of these together, 4 plus 4 plus 6 plus 6 is 20, plus 5 plus 2 plus 3 equals 25, 6, 7 equals 30. 32 minus 30 is 2, so the remaining people here are 2. So all sections are filled in there for 3 marks. One of the students with both a desktop computer and a laptop is chosen at random. So desktop computer and a laptop is this region here. There are 9 of those people. And the question says, find the probability that this student also has a tablet. So out of those 9 people, 5 of them have a tablet. So the probability of them having a tablet, after seeing as that they're being chosen out of that very small subset of people who have both a desktop computer and a laptop, is 5 out of 9. The function f is defined as f of x equals x minus 6 over 2. Find f of 8. So f of 8 is, I just replace the x with the 8. 8 minus 6 over 2 is 2 over 2, which equals 1. Express the inverse function f to the minus 1 in the form f to the minus 1 of x equals. So, in this, I think about what's happened to the x. X, when I did the function of x, I subtracted 6 to get x minus 6, and then I divided by 2 to get x minus 6 over 2. So working backwards, start with my x, multiply it by 2, and that will get me to 2x, doing the inverse operation to each one. And then, instead of subtracting 6, I add 6, which gives me to 2x plus 6. So the inverse function is 2x plus 6. And to check that that works, I'll take a value of x, a simple value of x, let's say 6, because it's going to be subtracted from that, or 0, I'll take 0. And just check, say, f of 0 equals 0 minus 6 over 2 minus 6 over 2 is minus 3. F to the minus 1 of minus 3, if I do that, that is 2 times minus 3 is minus 6, plus 6 is 0, so it works. My inverse function leads me back to the original input. I could have also tested that with this here. If I put 1 into this, 2 times 1 is 2, plus 6 gets me to 8, which is what I put into that one. So that's a good check that you've got your inverse function correct. The function g is defined as g of x equals the square root of x minus 4. Express the function g of f in the form g of f of x equals, and give your answer as simply as possible. So g of f of x means that I need to put the function f of x into g of x. So g of f of x is the square root of f of x minus 4, which is the square root of, if I look at f of x itself, x minus 6 over 2 minus 4. I suppose to simplify that, I can put it all over 2's s minus 6 over 2 minus 8 over 2, which is the square root of x minus 14 over 2. And that's as simple as I can go. Question 14. The diagram shows a prism. The triangle PQR is a cross-section of the prism, so that triangle follows the whole way through the prism. PR is 20 centimeters, MP is 12 centimeters. These are parallel because it's a prism, even though they don't look it in the diagram. PRQ is 30 degrees, that angle here, and PQR is 90 degrees as shown on the diagram. Calculate the size of the angle that the line MR makes with the plane RQLN. So RQLN is this sort of base of the prism here, and the line MR is that one there. In order to find this angle, I actually need to mark in a line here. We're talking about the angle between the line and the plane, so we're talking about this angle in here. That's the one I'm looking for. It's not the angle between the line and the front of the prism, or that angle and any other angle. It's just between that line and that whole plane surface. So give your answer correct to 1 decimal place. So in order to do that, I'm going to need to know the length of line MR. This is a prism, so that is a right angle there. So all the faces in a prism are rectangles. So that's going to enable me to work out MR using Pythagoras' theorem. I'm going to be able to work out ML because ML will be the same as PQ, and I can work that out using this line and this angle using right angle triangle trigonometric ratios. And once I've got that and that length, I'm going to be able to work out X also using trigonometric ratios. So first of all, MR squared is the hypotenuse, so that is 12 squared plus 20 squared, which is 544, I think. Yep. So MR is the square root of that, which isn't an exact answer, so I'm going to leave it as root 544 at the moment. I know that it's 23 on my calculator, 23.32380, and I'm going to use it to that number, that degree of accuracy in my further calculations, 23.32380, or in fact I might just use root 544 in my later calculations. PQ, if I look at this triangle here, P, Q, R, 30 degrees and 20, that means I've got a hypotenuse and I've got the angle here, and I'm looking for the opposite side, O. So I've got hypotenuse and opposite, so I'm using sine. Sine 30 equals opposite over hypotenuse. So opposite, which is PQ, is 20 sine 30. Sine 30 is a half, so 20 times a half is 10. So PQ is 10 centimeters, which means that ML is also 10 centimeters, because it's equal to PQ. It actually doesn't tell me to show all working here, so although I'm writing down the details of where everything's coming from, that won't necessarily be required for the marks as long as I get the right answer. But at the same time, in order to help get the right answer, it's good to have everything written down and to annotate the diagram as you go. So this leads me to my final triangle, which is RLM, right angle triangle. I know that this height ML is 10, and I know that this length here is root 544, and I'm looking for this angle X in here. So again, I've got opposite hypotenuse, haven't had to use the adjacent at all, so sine X equals opposite over hypotenuse, which is 10 over root 544. So angle X is inverse sine to the minus 1 of 10 over root 544. So on my calculator, I'm going to do square root 544, 10 divided by that answer, and then press shift sine to the minus 1 of that answer, and that gives me 25.38803, and I need to give my answer correct to one decimal place, so that is 25.4 degrees. And looking at that picture, 25.4 degrees, I can't tell whether it's totally right just by looking at the picture, but I can see that it's roughly correct. It should be a very small acute angle, and that's what it is. Question 15. A scientist is studying some rabbits. The rabbits have a disease that kills the rabbits. A population of 160 of these rabbits was reduced to 90 rabbits in 2 days. The rabbit population is decreasing exponentially. Work out how many of the 160 rabbits will still be alive at the end of 7 days. So in 2 days, the fact that it's decreasing exponentially means its number is being multiplied by x, some unknown number, and this, because it's decreasing, x is less than 0. Not 0, sorry, x is less than 1. X is a decimal number is what I'm looking for here. And I know that when it's multiplied by x for 2 days, that leaves me with 90. So if I write that out again, 160 x squared, 160 times x is 90. That means that x squared is 90 over 160. X is the square root of that. Square root of 9 over 16, which actually is 3/4. Didn't need a calculator for that because square root of 9 is 3 and square root of 16 is 4, and that's how surds work. I could have written that root 9 over 16 equals root 9 over root 16, and that would leave me to 3/4. So x equals 3/4, which is 0.75. After 2 days it's got to 90, so day 1 is 160, day 2 160 times by 0.75, day 3 160 times by 0.75 squared. When it gets down to day 7, that's going to be 160 times by 0.75 to the power of 6. I've taken a shortcut there. I've just noticed the pattern between 0.65 to the power of 1, sorry, 0.75 to the power of 1 after 2 days, 0.75 to the power of 2 after 3 days, so when it gets to 7 days, there are going to be 6 as the index number there. You could just write this out stage by stage and you'd get to the same answer. So on my calculator then, 160 times by 0.75 to the power of 6 is 28.4765, which leaves me with roughly 28 rabbits. The mark scheme I expect will say 28 or 29, and depending on how you interpret that number. But if you've shown working and shown you how you got there, then you will get the marks for that. 28 rabbits remaining. And I better check the question. Did it ask for rabbits remaining or how many have died over the time? Remaining alive, how many will still be alive? So that's my answer to the question. 28 rabbits remaining. Question 16. Work out the area of the quadrilateral ABCD. Give your answer correct to 3 significant figures. So it's a quadrilateral. I don't know that much about it, but I can see that this is a right-angled triangle here, triangle BAC, and the other one is not a right-angled triangle, but I have some measurements. This is clearly a rule, cosine rule, half AB sine C. The trigonometric rules are going to be involved in here. In order to work out this right-angled triangle, its area, I need to have its base that is perpendicular to its height, so I need to know AC. I can do that with the cosine rule because I've got these 2 sides. So cosine rule, and I'm looking for a missing side, so I'm looking for a squared equals b squared plus c squared minus 2bc cos a. This missing side, a squared, is AC. I can label it A. A squared equals 11.8 squared plus 7.4 squared minus 2 times 11.8 times 7.4 times cos of 132. I'm actually on my calculator going to do this stage by stage to check. So 11.8 squared plus 7.4 squared is 194. So it's 194 minus, and then on my calculator I'm going to do cos 132, multiply that by 7.4, and multiply that by 11.8. And that's a minus number, so I've got 194 minus 58.428. And on my calculator I'm just going to type in 194 minus that answer, and I know what I'm roughly expecting, which is above 200, 252.428. That tells me a squared. That seems... Oh, that's a squared. I was going to label that as a, but of course, looking at the diagram, if that had been 252 centimeters, that would have been far too long. So by checking that, I'm actually avoiding making that mistake where I might have forgotten to square root. So a is square root of that answer, which is 15.88799813. So I'm going to label that on there, my diagram, 15.88799813. So area ABC half times base times height. Which is 65.1407-ish. And area of ACD, other triangle, I'm going to have to use half AB sine C, but I've got the two sides already, so I don't need to use this one. Area of triangle ACD equals half AB sine C, which is half times 7.4 times 11.8 times sine 132, which is sine 132 multiplied by 11.8 multiplied by 7.4 divided by 2, 32.4457. Total area 65.1407, etc., plus 32.4457, which is 97.5864, etc. I need to give my answer correct to three significant figures, so just the first three digits that count. And of course I have to round that 5 up to a 6, so 97.6 centimeters squared. And just looking at that, is it roughly right? Well, if I imagine it as a rectangle that's sort of 8 by 10, that would be 80. It's bigger than that because it's 8 by a bit more than that. So that seems about right. It's not a completely ridiculous answer. Question 17. Y equals at squared minus 2at and x equals 2a root t. Express y in terms of x and a. Giving your answer in this form. We'll worry about the form of the answer later. First of all, just looking at this, express y in terms of x and a. This, at the moment, y is expressed in terms of a and t. And so we need to get rid of those two versions of t. So I need to find an expression for t and for t squared. And they need to be in terms of x. So I'm going to start rearranging this one in order to get t on its own. So first of all, divide both sides by 2a. That gives me x over 2a equals root t. So square both sides. That's just my symbol for squaring both sides. That is x over 2a all squared equals t. I can now put that into this formula here. So y equals a times by t squared. So that's x over 2a squared, but that's t, and so that all of that needs to be squared as well to make it t squared, minus 2 lots of a times by t, which is x over 2a squared. And now I'm going to start looking at how this needs to be written out in the answer. It wants two fractions in terms of x and a. So I've got the basic setup of this, but I'm going to need to do some more work to expand these power brackets. So a over, I'm just going to do the inner one first. That's x squared over 2a squared is 4, 2 squared is 4, and a squared is a squared, and that needs to be squared, minus 2a times by x squared over 4a squared. If I think about cancelling terms here, I can't for this one yet, so I need to square that again. That's a times by x to the power of 4, 2 times 2 is 4, 4 squared is 16, a squared is a to the power of 4, minus, and this one I can start doing some cancelling. If I've got 2ax squared over 4a squared, I'll be able to cancel the 2 and the 4, so that'll be a 2 there. I can cancel one of the a's from each, so no a's up there at all, just leaving an x squared on the top, and this is now an a to the power of 1. So I'll just leave that first bit as it is, a times by x to the power of 4 over 16a to the power of 4, minus, this simplified version is x squared over 2a. And that's already in the way it's meant to be here. X to some power, integer power, x squared over 2a. Do the same with the first part. I've got a x to the 4 over 16 a to the power of 4. The only thing I can cancel here is one of these a's, so that becomes a to the power of 3 instead, minus x squared over 2a. So that leaves me with x to the power of 4 over 16a cubed minus x squared over 2a. And that fits the question. X to some power, 4. Some number, 16, a cubed, which I've got, minus the second bit. So, making sure I give my answer in the correct form, y equals x to the power of 4 over 16a cubed minus x squared over 2a. And I've shown that question. Difficult shuffling algebra question there. Lots of things to get wrong on the way. It's worth 4 marks, and obviously you have to do a lot of work for those 4 marks, but each stage of this will be worth some marks. Question 18. The histogram shows information about the lifetime of some electrical components, frequency density here, and lifetime in years. Work out the proportion of the components with a lifetime between 1 and 6 years. So for this, we don't actually need to work out the overall, we don't need to know how many electrical components are involved. We just need the proportion that are between 1 and 6 years. Remember that the area in a frequency density histogram, the area of each bar represents the frequency. So a lifetime between 1 and 6 years is here, this bit, this bit, this bit, and up to 6 years here. So let's look at the areas of each of those bars. I've got a gap of 1 there. So each of these is just going to be the width, 1 times by the height, which is, if that's 0.2, then that thick line is 0.1, and that must be 0.12. To check, 0.14, 0.16, 0.18, 0.2. So 1 times 0.12. This one is 1 times, again, width of 1, times by 0.32. This one is 1 times 0.38. And that's 1 times 0.52. And this is 1 times 0.16. So we've got 0.12 plus 0.32 plus 0.38 plus 0.52 plus 0.16. And that equals 1.5. The total area of this graph also has an additional 0.12 in here, 1 times 0.12, and over here an additional 0.16. So the majority we can see have a lifetime between 1 and 6 years. They're mostly in here. So I'm just adding those final bits, 1.5 plus 0.12 plus 0.16. Is 1.78. So the proportion is 1.5 out of the 1.78. This may seem confusing because you think, why are there 1.5 components? But it's actually that the area is proportional to the number of components, so it doesn't mean there are 1.5, it just means comparatively there are 1.5 compared to a total of 1.78. So 1.5 divided by 1.78 is 75/89 as a fraction in its simplest form, or roughly 0.843, so that would be 84.3%. I expect 75/89 is the mark scheme answer there. Hoping I haven't made a mistake with the areas involved there. Question 19. ABCD is a parallelogram. E is the midpoint of AB. So those are both equal, AE and EB. E is the midpoint of AB, F is the midpoint of DC. So those two sections are equal as well. Prove that a triangle AED, this one here, is congruent to triangle CFB. Proofs of congruence, we've either got angle, side, 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 or right angle triangle with a hypotenuse and knowing one other side. There's no right angle triangles here, so that's definitely out. If I look at this, I know that because it's a parallelogram, that angle is going to be equal to that angle. And I know that... what else do I know on this? Because it's a parallelogram, that length, which is half of that side, must be equal to that length, which is half of that side. And also, because it's a parallelogram, these sides must be equal. So that will give me side, angle, side. I'll be able to use side, angle, side in order to prove that. There may be other ways to do this as well. So starting this as a formal proof, now I've decided how I'm going to do this. Let's say if side, angle, side are equal, triangles are congruent. So first of all, let's say that AD equals CB, because opposite sides of a parallelogram are equal. Parallelogram are equal. I've got angle DAE equals angle FCB, because opposite angles in a quadrilateral in a parallelogram, opposite angles in a parallelogram are equal. And finally, AE equals CF, because both are half the opposite sides of a parallelogram. Opposite, I'll say equal. Opposite equal sides of a parallelogram. As I'm doing this, I'm assuming the mark scheme is, well, it will involve key phrases. It'll involve mentioning various key terms, and I'm just making sure that my proof is as watertight as possible by adding in key bits of information here as I'm going through. So, therefore, side angle side is true. So the triangles, so AED, triangle AED is congruent to triangle CFB. AED is congruent to triangle CFB. Hence prove that DE equals FB. So it's saying that DE equals FB. So I can do that by saying that if these triangles are congruent, then they must have equal sides. These sides have already been taken. They've all been already been used in the other proof, so I don't have to prove them again. And I can just show that these therefore must be equal length as well. So since triangle AED is congruent to triangle CFB, all sides have corresponding equal sides. SSS. I've got AD equals CB as above. AE equals CF as above. So DE must be equal to FB. And that's the end of the last question. If I've made any errors in there, I will correct them in the text below. So if you have any answers that you think are correct and you think that mine is wrong, check in the text below and I will make any corrections there.